Welcome to Lesson 2, the rational or inverse functions of a graph. This section should look similar to something we looked at before at the start of the school year, but there are some new things added in with the asymptotes or undefined values of the graph. So I'll just go through some examples for this section to help you understand how to get the graph that I've provided and what steps you can do to create the graphs yourself. So in the first example here, we're given this straight line. Remember that we're taking y equals 1 over x, so this cannot equal 0. So whatever function you're given, wherever it hits 0, then you know that the graph is undefined there and that you have an asymptote. This is also true if it's a straight line and you're going through the x-axis. So we have an asymptote going here at x equals 4, as well as y equals 0 all the way across. Once you've done that and identified your asymptotes, the first step is to draw the dotted lines. The second step that you can do is find points on your original graph that will indicate to you what the shape of the graph should look like. Now, we have no graph here and here, so you shouldn't have any values there. You need to keep that in mind when you're drawing your graphs. So what I did next was find points on the graph that went through either y equals +1 or y equals -1, and I made that a point on my graph, there and there. Then, after that, you want to think about what is 1 over x equal. So here we have a value of approximately 1/2. Well, 1 divided by 1/2 is equal to 2. So that gives you 2 plotting points. You could also go along here and graph it down with any additional points that you have, but the general shape of it will be that it curves here and approaches the asymptotes indefinitely. The same thing on the bottom here. We have this point at -1 as well as about 1/2. It's right here, and then just drawing your general shape. You can see that we have our domain and range. I wrote it both ways for you so that you could see where the domain and range went up to and didn't include the values. In the second example here, we have a parabola that is above the x-axis, and that makes it really easy to find the inverse of the graph because we're just taking the y values and making them into 1 over x. So here the graph at its lowest point is 1 over 2. So we'll have our first point at 1/2. And then if you look at around 4, it's like 1/4 on both sides. And then the graph will just go off into infinity, positive and negative, but never touching the line y equals 0. For our range, we have a maximum value of our inverse graph at 1/2, and it is kept above that 0 line. So 0 is less than y is less than or equal to 1/2. Notice the less than or equal to 1/2, that's an included point. 0 is a point that it cannot touch, so you don't include that equal symbol on the bottom there. In C, you have a parabola again, but that parabola dips below the x-axis, and you need to remember that the values will be undefined at 0. So you have these 2 points here that hit x. Those become your vertical asymptotes. And then the shape of the graph is something similar to this. You'll see this graph every single time you have a parabola that dips below the x-axis. It will have 2 vertical asymptotes and a horizontal asymptote at 0. And you'll just draw in the general shape, approximating it, use those points again at y equals 1. And then the same thing on the bottom here. In between those 2 asymptotes, we still have values. It's 1 over x. So here you have value of y equals -2. So it becomes -1/2. And then the points at 1 and 1 don't change. And it just continues off into negative infinity. The third graph that you have here, it doesn't go above the x-axis, but we still have inverse values. So the same thing, you want to just find some reference points. Here we have 1/2, so it will, of course, change to 2. Our points at 1 and 1 do not change, and the graph will just continue off into infinity. Notice that there's a minimum value for the y in the range and a maximum value that it can't touch 0. In this example, you're given y equals 1 over x, shown as your graph, and it asks you to draw the graph of y equals f of x. Now your x-axis is, your x-intercept is shown here because that's where your asymptote lies. So you know that the graph is going to go through this line. And then the other points that you can use as reference are here at 1, 1, 4, positive 1, and 2, negative 1. You can just plot those 2 points on there. And then you just use a ruler to draw your straight line for your original graph, y equals f of x. You know this isn't a parabola because it only has one vertical asymptote. If you look in the example down here, the parabolas typically have two vertical asymptotes. You know that this is just a linear function. Below that, we just have another example of drawing y equals 1 over x. So the same thing here, you just take your original graph. Remember, this parabola dips below 0, so you will have an asymptote where it hits 0 on the x-axis, and then you'll have that nice parabola shape in between the asymptotes, and for the positive values of this parabola, you'll have those two graphs going off into infinity in either direction, but never touching your asymptotes. The same thing on the graph on the right-hand side, we have an asymptote at y equals x equals negative 1. And then you just find your points where y equals positive 1 and negative 1. Now you have 3 points. You can just use your ruler and draw your graph in. You can see on the right-hand graph here, we have this original straight line. So you want to just pick the points where it crosses the x-axis. That's right here. You have your vertical asymptote at negative 1. And then just find 2 points on the line where it equals negative 1. Plot, and then draw your general shape in. There are no practice questions at the end of this section, but you can continue on and complete the lesson 2 homework.